Good day, everyone. Today, we will present to you a step-by-step procedure for instrumental variables using a time series data. For this video, we will be using the dataset from Asian Development Bank Key Indicators for Asia and the Pacific 2019, specifically the Philippines. The dependent variable is population growth, followed by government consumption, exports of goods and services, imports of goods and services, GDP, and consumer price index as its independent variables. Our data from these variables is from year 2000 to year 2018. First, let's transfer our Excel dataset to the Stata data editor. Afterwards, set the dataset in the time series using the command tsetyear. Next, we need to transform first the other variables into logarithmic form before regressing. Our command reg government consumption log is equals to log open parenthesis government consumption close parenthesis. We need to repeat inputting this command for all necessary variables.
Another thing before regressing, we need to identify the variable that is in need of a proxy. Please be reminded that the variables we used in this video are for illustration purposes only. In doing instrument variable, the variables you include should be backed by literature. This includes identifying the variable that is in need of a proxy as well as the candidate instrument. In this case, our endogenous variable is exports of goods and services, and our candidate variable is imports of goods and services, with population growth as our dependent variable. All the other variables not mentioned are our control variables. Now let us begin with the ordinary least squares. Click first the dependent variable and all the other control variables. Remember to not include the variable of interest or the candidate instrument. Run the OLS. Take note that the results of the OLS is our initial regression. Now, let's look for possible signs of multicollinearity. The command VIF. Generally, a VIF above 4 indicates that multicollinearity might exist, and further investigation is required. When VIF is higher than 10, there is a significant multicollinearity that needs to be corrected. Next, let's check for heteroscedasticity. The command stat-imtest, white. Let's just go on. Stat D Watson. Since it is a time series, it is expected that there is a serial correlation, and we address this via Newey West, the modern approach. Newey, insert the dependent variable, population growth, and all the other control variables, comma, lag, open parenthesis, 1, close parenthesis. We are now done with OLS. The next procedures are for the instrumental variables. Now, we need to find a valid and strong instrument. What makes an instrument valid? It's the twin criteria of exogeneity and relevance. Based on the initial regression, we suspect exports of goods and services as the endogenous variable since it relatively has the largest coefficient and is most significant at 5%, thus exposing itself to an omitted variable problem. With this, we need to find an instrument variable that is potentially not related to all variables that we have excluded. Instead, it must be exogenous and statistically significant to exports of goods and services. Thus, it must also be relevant. In this case, we have identified imports of goods and services as a viable candidate instrument.
In testing if the instrument is valid and strong, we have 3 steps to follow. Step 1. You need to regress the endogenous variable, the chosen candidate for instrument variable, and lastly, the control variables. For the second step, you need to regress the dependent variable, which is population growth, to the independent variable, or exports of goods and services, along with the control variables. For the third and last step of the test for valid and strong instruments, you need to regress the dependent variable, replace the endogenous variable with your instrument variable, which is imports of goods and services, and lastly, your control variables. It is a strong and valid instrument if the standard error of the instrument variable is greater than the endogenous variable. With this, imports of goods and services is both a valid and strong instrument because its standard error is greater than the exports of goods and services. We now proceed with the Hausmann's test for endogeneity.
The Hausmann's test is a test that detects endogenous regressors which have values that are determined by other variables in the system in a regression model. Having endogenous regressors in a model will cause ordinary least squares estimators to fail, as one of the assumptions of OLS is that there is no correlation between a predictor variable and the error term, so instrumental variables can be used as an alternative in this case. However, before you can decide on the best regression method, you first have to figure out if your predictor variables are endogenous, which can be done through the Hausmann's test. Hausmann's test for endogeneity also has 3 steps. Step 1. Repeat the first step in testing the valid and strong instrument. Our command, reg, exports of goods and services log, imports of goods and services log, and our control variables. Step 2. We will generate another variable. The variable is called residual. Our command, predict R, reseed. Take a look. R is now under the list of variables. Last step. Last step is we run the original OLS again, but this time with the variable R. Our command, reg, population growth, exports of goods and services, our control variables, and now R. If the residual is statistically significant, then exports of goods and services is an endogenous variable. In this case, R is statistically significant at 5%. Therefore, it has been proven that there is an endogeneity problem, but now we have a valid and strong instrument.
Now, it's time for our final estimates. Since we used instrument variables, now we will use the two-stage least square model, 2SLS. Our command, IV regress, 2SLS, population growth, control var, open parenthesis, endo var equals IV, close parenthesis. If you're wondering, this will come out as endo var in label only, but the values used are the values of our now proven instrument variable. And there we have it.
Just a reminder, if we don't have a problem in heteroskedasticity and serial correlation, our final estimates could be either Newby-West or Price-Winston. Here, in our case, since we have proven that we have a problem in endogeneity, we use 2SLS, or two-stage least square model, for our final estimates. We hope that you learned something from this lecture video. See you next time!